Hello, welcome back to Mrs. Torres' YouTube channel. Today we are going to talk about multiplying and dividing radicals. Remember, that is just what we call that square root symbol. Alright, let's look at an easy one first. The square root of 2 times the square root of 50. When we are multiplying square roots, we can just multiply what's underneath. So, 2 times 50 gives us 100. The square root of 100 is 10. All right, let's look at a different one. 3 root 8 times the square root of 3. Now, when you have something like this, we can only multiply what's under the square roots. So the 3 doesn't have anything to multiply with, right? So that would just stay the same. 8 times 3 gives us 24. Now, we are not done yet. We've multiplied, but now we need to simplify, right? So if we simplify the square root of 24, we could do 2 and 12, 2 and 6, 2 and 3. So that would simplify to, we have a pair of 2's there, 2 root 6. But remember, we have this 3, so it's 3 times 2 root 6, which gives us 6 root 6. And remember, we can always check these in our calculators by putting in our answer and the original expression and see if we get the same long decimal. So 3 root 8 times the square root of 3. We get this long decimal, 14.6969, blah, blah, blah. 6 root 6. We get the same thing, so we know we are correct. All right, how about if I gave you this one? 5 root 3 times 6 minus 2 root 12. It looks a little intimidating, but let's think about this. All it is a number being distributed to something else, right? If we replace these radicals with variables for a second, so let's say it's 5x times 6 minus 2y. We can absolutely distribute that, right? 30x, blah, blah, blah. So the same thing applies here. We're going to take 5 root 3 times 6. The 6 is not under the square root, right? So we're going to multiply it by the 5. So 5 times 6 gives us 30. There's no square root attached to the 6, so we're just going to say times the square root of 3. Then we need to distribute to our other term, multiply the outside numbers. 5 times 2 gives us 10, and don't forget it's negative 10. And then the square root of 3 times the square root of 12 gives us the square root of 36. Now we need to simplify our square roots. We can't do anything with the square root of 3, so I'm just going to bring that down. Minus, oh, I think that's perfect square. The square root of 36 is 6. So this is just 10 times 6. So we've got 30 root 3 minus 60. And that's it for that one. All right, let's try another one here. Give me 1 second. How about this guy? 5 minus 4 root 5 times negative 2 plus the square root of 5. So now we have 2 binomials. But you know how to do that. It's just double distribution or FOIL, whatever method you prefer. So we've got 5 times negative 2. That gives us negative 10. Then 5 times the square root of 5. That's just 5 root 5. Then we have negative 4 root 5 times negative 2. So that's going to give us positive 4 times 2 gives us 8. And then we just have the square root of 5 because there's no root over here. Then we have negative 4 root 5 times the square root of 5. So negative 4 square root 25, right? Because 5 times 5 gives us 25. All right, let's simplify a little bit. We have some like terms that we can combine here. So negative 10 plus 13 root 5. I think that's a perfect square. The square root of 25 gives us 5. So that's minus 4 times 5. We can't simplify the square root of 5, but we can simplify this. So we've got negative 10 plus 13 root 5 minus 20. And then we have two constants here, so we can combine those. So we've got 13 root 5 minus 30. Basically, it's simple math. We just threw some square roots in there. Now, I want you to notice something. Up here, when I multiplied negative 4 root 5 times the square root of 5, that gave us 4 root 25. And the square root of 25 was just 5, right? Which makes sense because the square root of 5 times the square root of 5 is really just the square root of 5 squared, right? That's what squared means. And square rooting something and squaring something are opposite operations. So if you are ever multiplying the square root of the same number by itself, it's just going to give you the number underneath, basically canceling out that radical. Okay, the last thing that we need to talk about is called rationalizing the denominator. Which means eliminating the radicals or the square roots in your denominator. A long time ago, mathematicians decided that numbers are much easier to work with if they don't have a square root in the denominator. So that's why we need to learn to rationalize our denominators. So let's see how we would do that. Let's say I've got the square root of 10 over the square root of 3. So we're trying to eliminate this square root of 3. Well, think about what I just talked about up here. The square root of 5 times the square root of 5 is 5. So I eliminated my square root. So I need to multiply this square root of 3 times the square root of 3, right? Because that's going to cancel out and just be 3. However, we can't just multiply numbers by random numbers. We need to multiply by a number that won't change our number, our original number here. Well, that's 1. If you multiply 1 by anything, it's just going to spit out your original number. So we need to multiply this by the square root of 3 over the square root of 3. Because if you divide any number by itself, that's just going to be 1. This is really 1. It's just a fancy way to write it. Now we just multiply like we know how. Square root of 10 times the square root of 3 gives us the square root of 30. And the square root of 3 times the square root of 3 is 3. And then we would look to simplify the square root of 30. So it's going to give us 3, 10, 2, and 5. So 3 times 2 times 5. There are no doubles, so this would be our final answer. Now I know these numbers, it's still kind of an ugly number, right? But we eliminated the square root in the bottom, and that's what we wanted to do. All right, how about this one? So we've got 2 root 18 over 3 root 3. So before I do anything, I'm actually going to simplify my square root of 18. I think it's easier to work with smaller numbers under our square roots. So let's simplify 18. We've got 2, 9, splits into 3 and 3. So this would be 3 root 2, right? And of course we have a 2 here. So this is going to be 3 times 2 is 6 root 2 over 3 root 3. I think doing that in the beginning just makes your life a little easier. Now we need to rationalize the denominator. We only need to multiply by what's underneath the square root. So we don't need to multiply by 3 root 3. We can just multiply by root 3 over root 3. All right, now let's multiply. So 6 times, there's nothing on the outside here, so we're just going to leave that as 6. Square root of 2 times the square root of 3 is the square root of 6. Now be very careful. We have 3 root 3 times the square root of 3. So 3 times 1 just gives us 3. Then we have the square root of 3 times the square root of 3, which is really the square root of 9. But we know the square root of 9 is 3, right? So we have 6 root 6 over 3 times 3. So we have 6 root 6 over 9. And then our last step, which we didn't have to do up here because we didn't have a coefficient there, you want to see if you can simplify your coefficients at all. So our coefficients are 6 over 9. So you think of that as a fraction. We could simplify, right? We could divide them both by 3, and we'd get 2 root 6 over 3. And that would be our final answer. All right, 2 more examples. How about this one? Square root of 12 over the square root of 16. So we want to get rid of that square root in the denominator. Well, it's a perfect square. So we can say the square root of 12 over 4. Now we still want to simplify our square roots. So we want to simplify the square root of 12. That's 2, 6. So 2 root 3 over 4. And then again, we want to look at the coefficient. So 2 over 4 could simplify to 1 over 2. So the square root of 3 over 2. It's not wrong if you write that 1 out front, but it's not really necessary. It's like when you have 1x, you just write x. All right. Last example here. The square root of 7 over 5 root 14. So we first look, can we simplify either of our square roots? Do we have any perfect squares? Doesn't look like it because this is a prime number and this we could just break down into 7 and 2. So we're just going to have to live with it. We want to rationalize the denominator. So we're going to multiply by the square root of 14 over the square root of 14. Then we've just got to do our math. So 7 times 14 gives us 98. 5 times, remember there's a 1 out front here, so 5. And then the square root of 14 times the square root of 14. We know that they're just going to cancel out. And that's just going to give us 14. Then we need to simplify. So let's see if we can simplify the square root of 98. We can break that down into 2 and 49. 49 breaks down into 7 and 7. So we've got 7 root 2 over 5 times 14 gives us 70. So our radicals are all simplified. Now let's reduce our fraction. 7 divided by 70, or sorry, 7 over 70. simplifies to 1 over 10, so we just leave this as the square root of 2 over 10. All right, I know this was a little lengthy, but there was a lot to show you in this one. See you later.